Good afternoon. We're looking at coping with the smart grid using a smartphone. A little disclaimer before I get started. First of all, I'm not affiliated with any utility. I do not sell smartphones nor smartphone plans, and I have no really fancy gizmos in the trunk of my car for sale after my presentation. I am, however, Associate Professor of Sustainable Energy Systems at Rock Valley College, and also work as the Academic Chair there for Sustainable Energy Systems. This presentation is a collaboration between myself and Dr. Tom Lombardo, who also is at Rock Valley College. The smart grid is looming. The smart grid is imminent in all of our futures. If you use electricity, you're going to run into the smart grid. The smart grid rollout gives us a couple of options. First is we can remain energy consumers, where we simply get our bill each month, complain about it, and tell people to start turning out lights. Alternatively, we can become energy citizens, where we start learning how to manage our energy usage, reduce it to reduce our bills, and with that knowledge, we're supporting the smart grid, which incorporates a lot of the renewable energy that many of us feel is important to the Strategic Energy Initiative. The first indication that the smart grid is going to visit you is when a technician comes by and takes the old analog spinning disc meter away and leaves this spanky new digital meter. It's much more than a digital meter, though, in that it provides two-way communications between your home and an area network. The smart grid and you, as soon as you get the meter, you have access to some online tools. You can manage your energy, so you get some feedback about real-time use. You can get a high usage alert if you define a parameter, and if it goes above that, you want to know about it. And you also get weekly reports summarizing your daily energy use. There also are voluntary peak time energy reduction plans to save money. Not mandatory, voluntary. Rock Valley College education. Rock Valley College established a Sustainable Energy Systems degree in 2009. We also have then, well, it's in Sustainable Energy Systems, and then also in that curriculum is the smart grid as a component. So you can see some of the details of that curriculum where it focuses primarily on electronics. We do get into some renewable energy generation like small wind and photovoltaics. The National Electric Code is included not because we want to train electricians or installers, but because that establishes good design practices for safe systems. And that all comes together through system design, and then finally, yes, we interface with the smart grid. We're also fortunate enough to have some smart grid trainers. These are produced by a company called Marcraft, which is located in Oregon. The trainers were purchased through a grant from iGen, which is the Illinois Green Economy Network, which links together 48 community college campuses across Illinois. The grant for $50,000 allowed us to purchase 5 of these systems and to begin training our student technicians. At the far right, you see circuit breakers. That would be the circuit breaker panel most of us have in our homes. Smart meters on the left. The 2 white units at the very top on the right is a smart thermostat that you can program and much more, and then a whole home energy monitor. Also, Rock Valley College is fortunate enough to have a serious linkage with a place called Freedom Field Renewable Energy. It's a not-for-profit. It's located on the Rock River, as you can see. It's part of the Rock River Water Reclamation District. The facility is a not-for-profit again. It's funded by Winnebago County. And for us, it serves as a living laboratory. So that means we have real solar thermal systems. We have real LED lighting systems. We have wind turbines, photovoltaics, all different systems that our students can actually get their hands on, modify with permission, and explore. If we start with the beginning of the grid, 19th century roots, of course there's Thomas Edison, who of course came up with a light bulb, and being the businessman, entrepreneur that he was, gee, I need to sell light bulbs, so more people need electrical power. So he's credited in 1882 with the Pearl Street, New York City, first centralized power station. And Edison was an advocate of direct current. Meanwhile, Tesla, in 1888, released a paper that described alternating current and some of the advantages of alternating current, namely for the use of transformers, which are inherent in our grid today, and also AC motors, which are very important for manufacturing and industry, as well as a lot of our home appliances. The evidence of the 19th century grid still remains. You see an aging infrastructure on the left, and you see an old fossil fuel plant on the right. A lot of coal is still used to generate electricity today, but it is being phased out because it's getting too expensive. The topology of the grid is there's a central place of generation, like in the upper right-hand corner. It generates tens of thousands of volts, and for transmission, the voltage is elevated using a transformer to hundreds of thousands of volts. Makes its way along transmission lines. Usually there's another reduction somewhere in between, and then finally it gets into distribution, where we have commercial, industrial customers on the left, and then residential, small business consumers on the right. The grid on mainland is extremely impressive, very interconnected, as you can see. It can be broken down into three separate grids. There's the eastern grid, the western grid, and the Texas grid. You know, Texas is Texas, so they got to have their own grid. Inherent, though, with this structure is you have a generating plant, we have transmission lines, and it's susceptible to single-point failures. Now, there's within limits, the power company can route around the problems as much as possible, but still, for a lot of them, they have to go out and actually send a truck, and somebody has to do some repair work to get customers up. End user down in the bottom right, you know, that could be your home with the little pole outside, and a hungry squirrel bites through the lines, and next thing you know, you and your neighbors don't have power. Another problem with the current grid structure is it's not very efficient. We have energy conversion at the generating plant from natural gas, coal, diesel oil, something, and by time it gets generated, transmitted, and distributed, you may be looking at a total system efficiency of 30 to 51%. Pretty sad. The smart grid, a lot of people, when you start talking about smart grid or see mention of it on their electric bill, they immediately think, aha, it's another plot by the utility trying to raise my rates again. Well, it turns out that it is a global initiative, because these rising countries are facing the same kinds of problems. We just have an infrastructure we have to address. But Africa, Asia, Australia, Europe, North America, Canada, US, and South America all have smart grid initiatives. In 2010, the Department of Energy came up with 7 goals for the smart grid. The first, obviously, from the last slide, we want to improve transmission efficiency. Second, if there is a failure, we want the system to self-heal if possible, but certainly reduce the time to return to service after an interruption. Reduce costs for utilities and customers. You know, if you improve efficiency, in essence, that may eliminate the need to build another power generation plant. So in that sense, yes, it could reduce the costs for utilities, and because of the improvement in efficiency and that could help customers. Reduce peak demand. Peak demand is you take a time interval and look at when everybody turns everything on all at once, that would be the peak demand, and the power companies have to design to handle that peak demand. So it'd be nice if we could reduce it, and one strategy is to spread it out, as you'll see. Increase integration of large-scale renewable energy systems. Most of us, you've seen the wind farms on 3951 and elsewhere. So we know that those are out there. The Illinois and various states have developed legislation in general referred to as renewable portfolio standards. And these set up guidelines. Like in Illinois, it's being worked on, but it's still 25% of the energy generated by 2025 needs to be from renewable sources. So we'll talk some more about that in a bit. A lot of customers, notably like a hospital, they have their generation capability right nearby. It's by law. They can't afford to lose power. They have to make up for it. There's also a lot of companies, businesses that are using renewable energy systems. So the grid design is supposed to take care of that. Distributed means you have generation right at the point of use. And then 7 is improved security. Try to minimize single point failures. If we take a closer look at goal 1 and like how do they implement this with the smart grid, more efficient transmission of electricity, and you can see at the top the traditional distribution from a central point of generation through transmission distribution to the customers is subject to a lot of loss. The smart grid system, basically, yeah, we still have at the left a power station, but we can also have other systems, other generation systems embedded. So little factories may have photovoltaics on their roof or a wind turbine on their campus. Right in the center, we have wind turbines, a wind farm, and then solar farm. And yeah, the renewables are part of the mix. One of the big problems with renewables like wind and sun is the wind doesn't always blow and the sun doesn't always shine. So the thing that's being worked on right now, and the real challenge is energy storage. But somewhere, all of this is monitored in a control center where they look at the energy needed, the energy generated, and they manage there. There's a lot of YouTube videos out on that, but if you take a look at some of them, you'll see that the control centers look an awful lot like the bridge of the Starship Enterprise. The smart grid essentials, well, on the right we have perhaps a building. It could be a residence. A tight energy envelope is always a good thing to do. We need a customer portal and building EMS's energy management system. There's a link between the building and the utility, and that is going to be provided by the smart meter. We have photovoltaics that could be on a roof. Photovoltaics is becoming increasingly popular because of something called a microinverter. So you can actually build a system gradually, and you don't have to like invest $30,000 or $40,000 and put up a system. So most of us, along with my budget, you know, breaking it down into small bite-sized steps is very attractive. And no charge, but that wind turbine on a roof, bad idea. There's turbulence and it makes noise, vibrations. So if somebody tries to say, here, let's put a wind turbine on your roof, save the cost of a tower, thank you, no. Now, once your meter's installed, you're going to probably be notified by your utility that you have this option for a flat rate, like you come to know and love or hate, and then this time of use pricing. Well, when the full rollout occurs, it's going to be time of use. That's it. You'll have to pay severe penalties if you go flat rate. But time of use means that it's not only how much energy you use, but when you use it. For instance, if you see the graphs here, winter is on the left, summer is on the fall, green is the lowest price, red is like ouch. But roughly 9 p.m. to 7 a.m. on both summer and winter are good times to do things like run your dishwasher, do your laundry, and if you have an electric vehicle, charge the batteries in that window. The height prices, like if you look on the left, winter, you see at 5 p.m. to 9 p.m. is when the highest rates. Well, what happens at 5? Everybody comes home. They turn on their oven to cook that pizza. Oh, I forgot to run the dishwasher this morning. Oh, load of laundry. Might as well get a heads up on that. So, and of course, don't forget the TV. So you got all these things going on, increasing the demand from a lot of households. If you look at the right on summer, the highest time, demand occurs between 11 a.m. and 5 p.m. And that's when we have the heat of the day and when air conditioners are calling for the most cooling. One of the other things you can get from right now from your utility is generally a day ahead hourly price and the current hourly price. And as soon as you get a smart meter, you can actually look at your instantaneous price as well. Smart home technology. Real-time monitoring helps us control costs. Smart home technology can make the process much easier. Some people like playing around with smartphones and that sort of thing, but if we can come up with something where we just program it and set it, for me, I much prefer that. The next thing we have is the smart grid meter. Provides two-way communications and also energy management because the utility knows precisely what energy you're using and we also know how much energy we're using. The utility control part bothers people. Like if you're really concerned about conspiracies and Big Brother, the idea of the utility having some control over my house. Some aspect sounds pretty unnerving, alarming. But basically you can enter in agreements and get a fee reduction on your bill if you agree to let the utility have control, say of your air conditioning set point for a couple hours a day or what have you. The smart grid meter, we have what's called now a home area network. If you get all these smart things like a smart thermostat, a home energy monitor, smart outlets, they all communicate to the smart meter via a protocol called ZigBee. The smart meter, in turn, sends that data to the neighborhood area network, and there's different formats for that. It could be a cellular uplink, it could be regular Wi-Fi, or it could, again, be ZigBee. Depends on the utility design. And the neighborhood area network, we have the houses with the smart meters on the lower left. We have distribution operations, so they have real-time control and adjustment. And then, of course, everything goes up to the utility for data collection. The products you may buy for the smart home form what's called a wireless mesh network with ZigBee. And that means if you have, say, a module that can't quite communicate with the smart meter, they can relay between modules so that you get data transmission to the smart meter and back, sharing. On the right, there are some products. There's a Belkin Wemo, for instance. It doesn't interface to the smart meter. It uses Wi-Fi, so all you need is your wireless router. And you can get an application so you can look at energy usage and switch things on and off remotely. As far as the internet connection, we have on the far right the ZigBee network. You need some sort of gateway which will connect with your wireless modem. The gateway can be a separate module, or it could be included in like a programmable thermostat. If we take a look at homes and the smart meter, of course we mentioned the thermostat. We're used to like setting time and maybe temperature, but with the programmable thermostats, they can also look at pricing and make decisions about when to raise the temperature or lower the temperature. Solar modules, again, because of the microinverter and the low cost, many people are investing in solar photovoltaics to generate AC, alternating current. And if you generate more alternating current than you need, you can actually supply some of that to the utility. If you enter into a net metering agreement with the utility, you can get a credit on your bill. Smart appliances like washers, dryers, dishwashers can be programmed again to start when the pricing gets below a certain level, or not run if the price is above a certain level. Whether you have all the smart home appliances or not, as soon as you get a smart meter, you can enter into agreements like voluntary reduction on your peak demand and so forth. Plug-in electric vehicles. You know, there's more hybrids out there. There's totally electric vehicles, which means, gee, they need to be charged. So we know now you probably don't want to charge them when the rates are highest. But because these vehicles store electrical energy, it's also possible to use that energy in an emergency. Like if there were a grid failure, you could feed that DC into something called an inverter, which changes the DC to AC. Smart home devices. Grid Rabbit is one of the companies, but you can see smart home door sensors, window sensors, and so forth. So all these different things, again, interface on ZigBee. I had doubts about the camera until I got married, and my wife has an African gray parrot, and I have a cat. So I thought, maybe we better keep an eye on things. But I faked out the cat because I taught it how to meow. Thank you.